आगे बढ़ना, बढ़ते रहना, मुश्किलों से लड़ते रहना, मुश्किलों से लड़ते रहना, हाथ बढ़ाना, कमजोरों को सदा उठाना, मानवता की सेवा करना, मानवता की सेवा करना, ऐसा यहाँ रिवाज है। भूमिया तो भूमिया जीवन का आधार है, शिक्षा का सरताज है, श्री शंकराचार्य महाविद्यालय, श्री शंकराचार्य महाविद्यालय, श्री शंकराचार्य महाविद्यालय, शंकराचार्य महाविद्यालय, हमको नाज है, कर्मभूमिया तपो भूमिया जीवन का आधार है, शिक्षा का ताज है, शंकराचार्य महाविद्यालय, शंकराचार्य महाविद्यालय।
हाँ, good morning, ladies and gentlemen, to this magnificent, glorious day. I am Rishabh Singh from BCA final year, Sri Shankaracharya Mahavidyalaya. It gives me immense pleasure to welcome you all to the certificate training program on artificial intelligence conducted by Department of Computer Science, Sri Shankaracharya Mahavidyalaya. I welcome our chief guest, Dr. Nilamdhab Mishra, sir. And Dr. Mishra sir is a doctorate in computer science and information engineering from Zhejiang University, Taiwan. He completed his MCA from Utkal University, Odisha, and MTech in computer science and engineering from Biju Patnaik University of Technology, Odisha. He has 17 plus years of academic teaching and research experience from across recognized Indian, Taiwan, and African universities. He has over 25 publications in SCI, SCIE, and SCOPUS indexed and other peer-reviewed journals. ISBN books and chapters, Indian and Australian patents, IEEE conference proceedings.
Mishra sir has joined or not?
Yes, sir. Joined, sir.
Okay, fine.
He has also been a reviewer, associate editor, and additional board member in various peer-reviewed journals and conferences. Dr. Mishra is a recipient of multiple research fellowships from the Ministry of Education, Taiwan, Ministry of Science and Technologies, Taiwan, and CGU, Taiwan during his PhD. He has also worked on multiple funded research projects from most NSC and CGU Memorial Hospital, Taiwan. He has significant research contribution in the field of IoT, network-centric big data analytics, which integrates with cognitive apps, policies, and exploration. He is a member of professional bodies like CSI, ORCID, IAENG, ISRO-SET, ISRD, and ASR. Collaborate. His research areas include network-centric data analyst and exploration, data science, analytics and application, IoT, big data application, and cognitive app policy and exploration. Now I welcome our HOD, Thakur Devraj Singh sir from BCA Science, Computer Science, Sri Shankaracharya Mahavidyalaya.
Thank you, Rishabh. Good morning to all. First of all, I would like to thank each one of you for joining this 21-day certificate training program. Every year, department organizes such type certificate training program to enlighten the young mind and promote the participant at all levels. In this training program, the theme is based upon artificial intelligence. to help the student understand the result of artificial intelligence in human life. It will focus on the major issue, solution, and long-term effect associated with the artificial intelligence. Even though this program is markers of the success of our institution, it also allows us to meet some of the brilliant personality who became the key speaker for the occasion. With all those words, I am extremely delighted to pronounce that the key speaker for the day, Dr. Nilabdha Misra, Senior Assistant Professor, VIT Bhopal. I guarantee that today's lecture will be productive and worth your precious time. Thank you. Thank you very much.
Now I invite Dr. J. Durga Prasad Sir, Additional Director of Sri Sankaracharya Mahavidyalaya.
A very good afternoon, one and all. Am I audible, Devraj?
Yes, sir.
Okay, fine. Thank you. My respects to Dr. Nilamada Mishra ji. Namaskar, sir. It's very nice to have a great personality as good as Dr. Mishra sir here. Though this is the first time I am interacting him personally, but I have heard a lot about him, not only as a good and great researcher, but also a keen observer and a keen helper to research aspirants. And we can, if you want to know more about him, you just log on to websites of VIT Bhopal. You will be get good information not only about his personality, but if you connect with some of his students, definitely you will get the major breakthrough how research is done and what measures are to be taken to adopt to his step. As far as this CIC training program is concerned, this is the 11th day of the workshop, and my congratulations to departmental members for achieving this middle breakthrough. And I hope by 21 we will be having more such great personalities on our online platforms, so that our students will be benefited in the best possible manner. As far as Mishra sir is concerned, again my respects and thanks to him for giving his lecture in this particular platform and benefiting our students. And we will also be looking forward in future also, sir, to get associated with you, not only for the students but also for the faculties, to enhance us with more knowledge, to share us with more knowledge, and what you can say, the more scientific approach of doing a research. So I'm more overwhelmed by your presence here, sir, and I'm really grateful that you have accepted our invitation. And I hope in future also we will be getting your cooperation's blessings. Thank you, sir. Thank you very much, sir.
Sir, you can start the meeting now.
So, okay, so hello everybody. Good afternoon.
Good afternoon, sir.
Good afternoon, sir. Yeah, good afternoon, ma'am. Okay, so all esteemed dignitaries over here and all young enthusiasts. Okay, so I've shared the screen. I think it's visible to you all, right?
Yes, sir.
It is visible, sir.
Oh, okay, good. Sir. Okay, so today, mainly in context to the applied artificial intelligence, we'll see some progressive analytic strategy, particularly in context to data of things for intellectual applications. Okay, so mostly if we think about the artificial intelligence, the term artificial intelligence, so mostly we think about the man-made intelligence, man-made intelligence, because what sort of intelligence we have that we consider as the natural intelligence, and we use computational process. Sorry. So in order to make necessary transformation into some artificial form. So they're having a lot of applications, they're having a lot of transformation strategy. Okay, so in order to transform the natural intelligence into some sort of artificial intelligence, and also they're having a lot of applications associated with the artificial intelligence. So if we think about the development stage of artificial intelligence at the current stage, so mostly we'll find that we are at the weak AI stage or the narrow AI stage. That means whatever the AI-based applications we are going to develop at the current stage, that mostly dedicate what I meant to a single task-centric applications. But whenever we think about to move to a general AI or super AI, so then what happen? So that means the multiple tasks we can able to do by using a single AI-based applications or control applications. So that type of work still research going on in order to accomplish such type of task. So now let me introduce with you some key terms. So like we use, because AI is one of the integral part. So because the lot of terms are there, just like we can say that the artificial intelligence, the machine learning, okay, the data science, analytics. Okay, so particularly if we investigate those terms, so mostly we find that they are having strong correlations among those terms, strong correlations. Okay, so already we know that the AI is just like an elephant. So where we can able to touch, accordingly we can able to make the necessary perceive. So in order to acquire and capture the necessary knowledge. Okay, so this is one part, one snapshot we can say that. Okay, so regarding the context of the snapshots, just I have just given some key terms in order to describe the some part. Okay, only the few part, little part to describe. Just I have given some key terms, so like your data of things and IoT. Because whatever the data scenarios, if we think at the current stage, so mostly we find that what happened, also they are having more than 20 billions of devices connected globally. Okay, and it generates huge amount of data. So it may be any, or you can say that there are different computing devices, the smart devices. Okay, so that means so everywhere data there. Okay, so then if we think about the organizational context, so we find a lot of data generated from the that is edge devices. Okay, so that means we can say that so they are having the global connectivity of the computing devices from where the large scale data are generated. Okay, so now it's the time to use the data science tools, the analytic tools, the AI-based tools, the machine learning tools. So in order to transform those data into some set of cognitive insights, some knowledge-based insights, so by applying some analytic solutions. So now if we think about some sort of what happened, so transformations, so mostly we find the importance of the computational intelligence. So that is also an integral part of AI in techniques, what we say there. So in context to this computational intelligence, that means we can able to generate the intelligence, we can able to generate the insights. Okay, so by performing some sort of computations in order to acquire the knowledge, and that knowledge we can able to what happen use in order to develop some sort of AI-based models or solutions to generate cognitions, to generate some insights. Okay, so here what happens is just we can see that is just like your business intelligence. Okay, some we can use some the computational intelligence techniques like your some neural network techniques. We can use some sort of subcomputing techniques. We can use the fuzzy based techniques. We can use so we can make some hybridizations in context to neural network, in context to genetic, in context to fuzzy. So in order to build some sort of neurofuzzy inference systems. So now what happens if we think about the data sources, potential data sources? So mostly we think about the IoT edge point data because of the global connectivity among more than 20 billion, what we say, the IoT devices. It may be our cell phone, it may be any such of computing devices, what we say that. And those such scenarios, what happen, mostly try to what happen, generate the huge amount of data, big data scenarios. Okay, and also we try to think about some cashless analytic solutions. So in order to transform the data into some sort of business gold mines. Okay, so now in context to the discussions outline, just we just move through some sort of background analysis in context to the data science and analytics and some sort of the DST, that is your IoT DSA applications overview, and some sort of what happened the industrial automations applications, and on just we move to the conclusion and the future work. So now, in context to the convergence technologies of IoT DSA, so because I told that, so data science is the major stream, and analytics is one of the integral part of the data science. And artificial intelligence, machine learning, deep learning, transfer learning, causal learning, what sort of learning techniques we use, those are progressively integrated into the data science and analytics platform. So now if you think about the data sources, so mostly we have to connect with the IoT. So that's why we can say that the comprehensive the platform what we think that is your IoT DSA platform. So now if you think the progressive conversion technologies that we are going to integrate to IoT DSA, okay, so mostly we think about those scenarios like your the computational learning, the big data, IoTs, and the data science and knowledge analytics. Okay, so if we instigate the key motivations on IoT DSA, so mostly we find that what happened. So they're having a lot of IoT objects. That's I told more than 20 billion IoT objects. Individual device having its own ID, and they are having the global connectivity scenarios. So just if we imagine the trillions of such connections, then if we can what happen find that so the huge and bulk amount of data it generates globally per hour. Okay, and that will create the IoT big data scenarios, and it will create the several challenges in context to the current scenarios. So now this is the IoT data science environment. So here we can able to integrate the data science with the IoT because we try to consider the data of everything. So the data of everything means we try to assume the global connectivity scenarios among the IoT objects. We can say that it may be or the any place, any process or people or things or the time. And the most important thing is if we instigate the connection counter, so we find that in the 2015 scenario, current scenario already 50 billion crossed, not 20 billion, 50 billion, almost all it crossed. So regarding the connections, okay, so that means we can say that so that huge amount of data generated from the IoT S1 devices, okay, and those data are the assets in order to build the machine learning applications or some cognitive applications. So now, if we think about the data in IoT database, so what sort of data we can able to find? So But if we mostly what happen, we can able to find some statistics with the spatiotemporal data, some geospatial data. Also, we can able to think about some time chain data. Okay, so regarding the IoT edge point data, also we can able to see. But if we instigate regarding some structure of some sort of base or structure, so in context to the IoT database, so mostly we find some sort of structure, some sort of semi-structure, some sort of unstructured base. They're having no base to place the data. That means we see the unstructured base. So just like our email document, our opinionated data, product related data, the image data, the video data. So those sort of unstructured data mostly we get, that is 80%. Because if we have the structured data, so then we can able to generate the cognitive solutions, the AI-based solutions very effectively. But if we have the unstructured data, so then mostly it will create a lot of challenges in context to generating the cognitive solutions, the AI-based solutions. So they're having a rapid growing in context to the IoT database. So that means if we instigate the problems, mostly we find getting the data in terms of the volume, in terms of varieties, in terms of veracities, in terms of values. And in order also we can find the lot of anomalies, the ambiguous situations in context to the increasing volume, increasing velocities, increasing veracities. Okay, so that means what we have to do, we have to use some sort of AI-based system, some sort of AI integrated knowledge-based system. So in order to make some necessary transformations from data into cognitive actuations, to from cognitive decisions. So now if we instigate the per stream view, okay, so mostly we find that 94% organization that face challenges in data elicitation and analytics scenarios. Okay, and the organization that having the strong belief that if we can able to acquire the data analytics solutions, we can able to make some necessary refinement in context to the decision making process. So in context to improving the business planning, in context to improving the business strategy. So that means what we say that. So they're having more than 20 billions or trillion devices connected globally. The IoT edge point devices. It creates the huge data, the large scale data, the large volume data, large velocity data. So the streaming data. Okay, so that means they're having a lot of challenges. They're having a lot of complexities in context to the IoT scenarios. So for that, what we have, so we have the DSA, we have the data science and analytics solutions. So in order to resolve that problem. So now if we think about the motivational aspects, so mostly what happen, we can able to find a lot of frameworks integrated with the IoT DSA mechanisms, what we say some sort of information framework. We can able to what happen, move to instigate the different case-based scenario analysis. We can able to make some sort of configurations regarding the representative data set preparations. We can able to prepare the data with respect to the desired scale in order to fit with the applications. We can able to use the different AI-based convergence technologies in order to make the necessary transformations into the intelligence. So we can able to make some sort of performance analysis in order to minimize or reduce the error during the prediction process. So now it's the time to instigate the background of the data science and analytics. So what we say that if we think about the science, So science means what happened. So it's always suggest to use some systematic process or systematic methodology in order to do some kind of tasks. Okay, so that means science always suggests to move through a systematic study. So now if we integrate the science with the data, so that means we try to what happens, so the build and organize the data in order to generate some sort of knowledge. That means if we find the different promises of the data science, the intellectual applications, corresponding intellectual applications. So we instigate that, we observe that. So mostly what happen, we have to consider the data as one of the asset, because whatever the AI based solutions, the applied AI solutions or machine learning solutions or cognitive solutions we are going to generate. Okay, so the best thing is the data centric solutions, because that means the data is considered as the asset. So we have to consider the data. So we can go for the different pre-processing techniques. In order to transform the data, we can use the different transformation techniques in order to transform into the desired scale. Okay, so the most important initial thing is we have to understand the data. So if we can able to understand the data, then only we can able to make some sort of transformation to knowledge and inferences. So that means through data science, so we can able to extract knowledge from data. So then we can able to invoke some sort of knowledge discovery process in order to enable the analytic to generate the cognitions. So they're having the different correlations. If we find, so we see that, so the cognitive computing, the statistical computing, the analytic inferences, the knowledge-based engineering, the re-engineering, some sort of domain analysis is required, because we have to target to a specific domain. Whenever we think about any AI-based solutions, we have to target to a specific domain. We have to understand their tacit and implicit operations, their operational aspects, and accordingly we can able to what happen, understand their data perspectives. So then only we can able to what happen, understand their requirements to develop the technical solutions. Okay, so that means we have to correlate with several emerging technologies into the data science and analytics platform. So now, if the knowledge analytics, because if we have a lot of data, that means the data will be ultimately obsolete if we cannot able to transform into set of insights, set of knowledge, set of cognitions, and further if we can't able to transform into some sort of cognitive actuations. So that means the analytic is an integral part of the data science. Okay, and we can say that the analytic is one of the major part, and through which what happen, so we can able to make some instigated in context to some logical analysis. We can able to instigate regarding the historical investigation, historical studies. We can able to instigate some potential trends, the resource trends, and also we can able to what happen, so explore some sort of decisions, effective decisions for the organizations, because the organizations they are investing a lot in order to acquire the data science solutions, the AI-based, AI integrated data science solutions, because they try to solve their problem, business problem. Okay, so they try to make some necessary refinement by enabling some auto recognition capability, auto transmission capability, the auto tracking capability. Okay, and that means through which what happen, so the organization can able to increase their global competencies. So that means ultimately the organizations from large and huge amount of data, so try to acquire and gain the knowledge and insights from data in order to increase their competency level. So now if we investigate the evolutions of the data science and analytics, so mostly from 1960, if we instigate to till date, so we'll find that the lot of evolution starting from the standard or standalone data pre-processing to exploratory analysis to integration of the classifications, mining the discovery, to some sort of integration to the statistical computing, knowledge discovery, or to analytics and fact-based decisions, to statistics and the machine learning, what we say statistical machine learning integrations. But if we see the current stage from 2012 to till date, so we'll find a lot of technological in that is amendment. So into the data science and analytics platform. So we can say that the cognitive learning or computational intelligence integrations, the IoT and analytic integrations along with the big data integrations. And if we find and if we try to link to the platform, so we can able to what happen? So find the integration of the cloud-based environment, the fog-based environment, and other the distributed computing environment into the data science and analytic platform. Because if we have the AI based solutions, if we can able to generate some AI based solutions, then we need a platform in order to implement that solutions. So now they're having a lot of applications. Just I have given some applications so for the investigation purpose. Okay, so now if we observe the different IoT DSA applications. So mostly what happen, so we can able to instigate through the different cases. We can able to identify their sort of requirements in context to the data requirements, in context to their what happen the technical requirements, their transformation requirements, their analytics requirements, their report requirements. Okay, so those things we have to instigate, and accordingly we can able to design and configure the IoT architecture. We can able to involve some sort of collection elicitation process, some sort of cleaning process, some sort of exploration process. So then only we can able to what happen also use those cleaned and confirmed data by integrating with the platform in order to generate the cognitive insights for the specified applications. So now this is my own research framework that I have given here. So particularly if we integrate the IoT DSA for the analytics and applications, so mostly we find that they are having number of applications starting from the consumer and analytics to the industrial to BI service to elderly care, healthy aging applications to the safety monitoring application to enterprise and applications. So mostly we find that they are having the different types of analytic techniques. Those analytic techniques we mostly say the AI-driven analytic techniques. We can able to use in context to the structural analytics, the conceptual analytics, logical, diagnostic, predictive, some sort of ontological analytics, some sort of predictive, descriptive, optimized analytics. So we can able to use in context to those applications. So in order to build the cognitive insights, in order to generate the cognitive decisions, in order to generate the cognitive actuations, in order to act on the smart environment. So this is one BI, where the business intelligence analytics and inferences. So the main aim is we have to enable some sort of inference for the directory service. Okay, so if we think about the analytic operations, that means we have to integrate the BI case analytics, some diagnostic solutions, some computational intelligence, and the learning solutions. We have to integrate particularly here if we instigate the architectural framework. So here what we observe that, so mostly in order to generate the intelligent solutions, solutions in order to infer the intelligent solutions. So mostly we have to integrate with the analytic solutions. Mostly we have to think about the different analytic solutions, the AI driven mechanisms in order to make the necessary transformations that we can potentially use in the form of the business queries, okay, and the corresponding what happened the stated solutions in order to convince to the customers or in order to increase the satisfaction level at the consumers end. So now if we instigate the safety monitoring applications, so particularly we can able to identify the task because whenever we think about some sort of AI based application modeling, okay, so mostly we have to think about what sort of tasks we need to accomplish, what exactly the aim, what sort of operations it needs to involve. Okay, that means so in context to the task identification, so we can able to go some sort of processing task, pre-processing task, some sort of inference task. We have to think about some sort of what happened environment in context to the that is what we say the sensors actuators environment. Because the sensors means what we term as IoT sensors. IoT sensors. Okay, so integrated with the actuators in the environment, integrated environment. So now what exactly the aim? So how an actuator gets an actions informations from the mesh sensors data because we know the IoT sensors it's can generate huge amount of data. Okay, and by taking the data, what happen? We cannot able to generate the cognitive actuations. Cognitive actuations. So we have to use some sort of analyze the AI-based analytics in order to transform the data into some cognitive actuations. And that actuation will perform on the smart environment for the purpose of automated recognitions, automated tracking, or auto recommendations. Okay, so that means the most important thing is so we have to follow a lot of cognitive processes, the knowledge-based processes. So in order to move from the data observations to the cognitive actuations. Okay, so that means we use from sensors and from IoT sensors, and we can get some observations. Then we can make some what happened transformations in or infer the knowledge. Then further we can able to make some transformations into some sort of cognitive analytics. So that analytics we can able to use in order to make some automated supervision at the industrial end in context to the safety and security monitoring prospects. That finally would happen in order to make some external control so we can able to connect to some external applications. So that means that we can able to enable some auto controlling operations in the context of that is industrial IoT what we say. So now if we think about some the cloud attached sensors applications, so that means the sensors networks there. Sensors network we can able to deploy, okay, for habitat monitoring cases, for any sort of remote monitoring cases we can able to use. Okay, so that means once we deploy the sensors and connect to the things through the gateway. Okay, so that means at the gateway level, so we can able to use some sort of AI-based solutions, some sort of analytic solutions, what happen in order to generate some actuations to work on that environment. Okay, because if we move from the sensors end to the gateway, sensors gateway end to the cloud gateway end, and from cloud gateway to cloud environment, and at the cloud environment, if we implement the solutions, AI-based solutions, the problem is that what happen? So it will consume more time to generate the solutions, and and that means what happen? So it will take more time to resolve the situations. So in order to handle the situations in a real time basis, in order to real time or in order to meet the real time requirement of the situations, so mostly we try to deploy the AI based solutions at the sensors gateway end. Okay, so that what happen, we can able to generate some cognitive actions to be immediately performed on the environment to resolve the situations. So this is the case. We can see this the elderly monitoring application case, because we know that human brain. Okay, so we are having the tacit knowledge, and our knowledge, particularly mostly what happen that circulated or the transport or the enabled through the brainwave patterns, the different brainwave patterns. And based on the specific brainwave patterns, what happen, so we can able to instigate the different activities of the humans. Okay, so that means if we can able to extract the human brainwave pattern, then what we can able to identify the specific thought process of the activities, and accordingly we can able to make some interactions with the external environment in order to give the real-time assistance. Particularly we know the elderly people. Okay, so the disabled people, so they can't able to do all sort of work. So that means that some assistive technology is required, some AI based assistive technology is required. Okay, so in order to provide what happened the real time assistance to them. Okay, so this is one of the applications, AI based applications, what we can say that. Okay, so where the main aim is we can able to generate some sort of AI based solutions, okay, in order to identify the human thought, the elderly thoughts and activities, so through which we can able to interact with the elderly, and also it can able to interact with some external applications. So in order to provide some a sort of assistance to the elderly. Okay, so the thing is that what happened, so we have to do lot of inference operations once we get the brainwave pattern, the signal or the data, what we say that the BWP data. So then what happened, so we have to instigate the different patterns with respect to the human activities. We have to use some the AI based or the applied AI based algorithms in order to generate some sort of inference solutions, and that solutions we can able to potentially use whatever or embed into the device. We can able to embed to the cell phone also the cognitive inference device, so in order to provide the real-time assistance and solutions to the elderly. Okay, so this is the work we have done at the Taiwan. So what happened? So we try to build some sort of that is your smart computing technologies. Okay, we try to embed into the some smart wire, because we know that okay what happened. So if we can able to measure some sort of physiological signals, and we can able to transform the signals into some sort of what happened cognitions, or then it can be used potentially used what happened, so into the different the device context. Okay, so that means we can able to once we develop some sort of analytics algorithms, then we can try to make into the technical transformations and try to embed into the device in order to perform some real time use. Okay, so that means in context to the developing or designing of the smart coat, smart belt, smart hat, or the smart coat or any smart shoes. Okay, so we can able to use some sort of that is AI based embedding technologies. Okay, so in order to generate some sort of that is assistive cognitions, the AI based solutions that can be potentially used for the welfare of the human. Okay, so now just I have highlighted some sort of cases, some instances just I have highlighted with respect to the DSA operations. Okay, they're having a lot of operations. We can able to use some analytic solutions, and in order to upgrade the solutions, we can able to use some reanalytic cases also we can able to use. Okay, so now if you think about the industrial IoT cases, because the large number of machines are there, series of machines are there, that those machines can be operated what happen without any human interventions autonomously. Okay, so that because of the technological integrations, we can able to integrate the IoTs, the computational intelligence, the big data analytics, the industrial internet platforms, and mostly what happen, we try to generate some sort of actuations to operate those machines without any human interventions. Okay, so this is a general framework what we can say that because if you instigate the individual machine configurations, you will get a lot of sensors are there, a lot of sensors are there, and we can able to get the periodical readings from the those machines. Okay, and it will and those data are needs to what happen the transport to the intelligent unit in order to generate the that is decisions. That means the course of actions, set of actuations. Okay, and based on the actuations, what happen, it will direct to the microcontroller of the machines to perform the automated operations, controlling operations. Okay, so many frameworks are there. This is one of the framework we use, particularly in the case of automation environment. Okay, with high industrial internet connectivity, what we say that in the industrial IoT perspectives. Okay, so we can the main aim is what happen once we get the aggregated data. So then, what sort of AI-based techniques we can able to use? What sort of storage techniques we can able to use? What sort of cognitive tools we can able to use? So in order to transform into the cognitive decisions, plans, and actuations. And accordingly, it will direct to the microcontroller to act on the machines in order to perform some automated supervisions or automated monitoring cases. Okay, so particularly what input we can able to take. So we can able to take the periodic aggregated data streams. Then we can go for some sort of classification, some sort of identifications. Okay, so try to generate what happened, the set of patterns, set of insights, set of decisions, the set of selective course of actions, cognitive actuations. Okay, and accordingly what happened, the based on the selective cognitive actuation, it will perform on the machines for the automated smart operations. Okay, so now they're having the different functional units, just like from sensing to applications. Okay, so if we think about the from sensing to transport to management to processing to applications, because directly we can't able to use the data from the sensing to applications. So in between that, they are having number of layers that we need to pass. And the most important thing is we have to investigate at which layer we can able to use the AI-based solutions or applied AI-based solutions, okay, in order to make the necessary transformations. Okay, so they're having the number of that is your analysis in context to the functional aspects. What we say that okay, this is one of the snapshots just I have given here. Suppose input we can able to data clusters, we can able to take the input, we can able to what happen execute the learning system. That learning system is an AI based system. The AI based system we can able to use in order to what happen, so it generate the output, the input output, and the input output what happen in context the input output we try to minimize the error in order to increase the performance of the actuations. And the mostly we try to use some that is your real time neural network structure. The neural network structure we can use, and the neural network structure what happen instead of taking some the random weights what happen we can use some the fortified weights, okay, in order to generate the some that is your real-time solutions, okay, with solutions, okay, with effective performance measure. Okay, so they're having here we just instigate the different machine loads, the real-time loads. Okay, so accordingly, what happen we can able to instigate the corresponding measure the deviations, the variations. So in context to what happen, the safety, the reliability, okay, reliability. Okay, because if we will not feel the reliable or if we will not trust on the machine, okay, so then what happens? It creates a problem because we have to believe on the machine. We should have the strong belief that okay, whatever the assistive technologies we are going to incorporate to the machine, so through that assistive technologies what happen, we can able to get some benefits, and it can able to help us in an optimistic way or positive way. Okay, so they're having the different error computations mechanism we can able to use. So in order to increase the performance by considering the target. Okay, so this is the reliability measure aspects we can able to use. Okay, so we consider the bias and deviations, and accordingly we try to what happen go for the reliability machine learning distributions. We think about the safety factor measurement, the reliability measurement. Okay, so those must be instigated what happen in order to enable the smart activities in the automated environment. Okay, so now if we think the initial effort in context to the data science and analytics, so mostly we find what happen at the domain level. We need to divert some effort in the process, in the data mining process. We need to divert some effort. So our normalization experts to use some convergence technologies. Okay, so that in that case, what happened? We need to divert more and more effort. Okay, and also the thing is that whatever the learning technologies today we are going to use that may be obsolete. So we have to progressively use the different that is your line learning technologies in order to upgrade the knowledge base, in order to upgrade the knowledge base, and according the system can able to work with the upgraded knowledge base in order to do some sort of automation operations, smart automation operations. So finally, we can say that okay, the IoT creates the big data problem, but we have the TSA solutions. We have the AI centric, the data science and analytics solutions, the applied AI centric data science and analytics solutions. We have the computational sort of computational intelligence solutions. So we have the some sort of the artificial and bioinspired that is solutions. So in order to resolve the problem with respect to the different application. Okay, so we use the different type technologies. What we can say that the range-based natural language query technologies we can able to use in the IoT as device. Okay, particularly in context to the business applications. Okay, so we can able to integrate the technologies in context to the advanced analytics support. Okay, and the most important thing, so huge amount of data there, how you can able to make necessary transformations to constitute and representative data. Okay, because we cannot able to consider the total data what happened to generate some sort of cognitions. So we have to transform into some sort of representative data, and that representative data what happened we consider as a substitute in order to instigate the study and implications for the intellectual domain applications. Okay, so now we see that the IoT will create huge volume of data, making the discovery of insights more critical. Often what happens, the analytic process will need to be automated. So that means we can say that it is a never-ending process because they're having what happened, the technological change management, the business change management, the requirement change management, all are moving in a dynamic way. So in order to dynamically cope up with those change managements, what happen, progressively we can able to incorporate more and more learning technologies, more and more intelligent technologies, more and more the computing technologies, the platforms into the what happen, the data science and analytics. So that means we have to increase some sort of that is AI-based analytics solutions, because I told currently we are at weak AI stage. Progressively we are moving to the general AI, then further super AI. Okay, so that means we have to instigate the traditional AI into some advanced AI or computational AI, what we say computational AI, because through some sort of computational AI, what happened, already the researchers got what happened, some sort of achievements on some extent. Okay, so these are my some research aspects on just reference as a reference I have given. Okay, so thank you for the great presence.
Thank you very much, sir. Nice presentation and nice information given by you, sir. काफी अच्छा लगा सर, आप जैसे पर्सन यहाँ पे पाए।
Thank you, sir. Thank you.
आपके लिए मतलब है हमारे लिए एक संजोग है कि आप जैसे पर्सनालिटी जो हमारे प्रोग्राम में और हमारे प्रोग्राम को सक्सेसफुल बनाया सर। के लिए मैं आपका बहुत बहुत धन्यवाद देता हूँ, क्योंकि आप लोग, मुझे पता है कि काफी बिजी शेड्यूल रहता है और आपने समय निकाला, इसके लिए मैं थैंक यू बोलता हूँ। और पूनम मैडम ने भी काफी आपसे वहाँ पे कनेक्ट किया और आपने समय दिया सर। थैंक यू वेरी मच सर।
ओके सर, थैंक यू सर, थैंक्स अ लॉट सर, थैंक यू ऑल।
Good afternoon, sir. Myself Ishita Sharma, student of MSc First Sem Computer Science. Sir, you have given many valuable inputs like advanced analytics, error analysis, representative data, and many more. But I have a doubt. Can you explain me with a real-time example of DOT? We are also providing YouTube links so those participants who are not able to join the meeting can go through YouTube link. We are also conducting a short quiz related to artificial intelligence whose link will be shared in your group. We are waiting for your valuable feedback whose link will be shared in your groups as well as in your YouTube description box. It is compulsory for all students to fill the feedback form as well as the quiz. Thank you.